Blood pressure dropping. Get a new bag up. On it.
This is a common problem in arthroscopy operating rooms, but first,
it's helpful to understand the context of an arthroscopy procedure. Arthroscopy is a minimally invasive surgery used to diagnose and treat joint conditions. During the procedure, irrigation fluid is continuously pumped into the joint to maintain pressure and ensure clear visibility for the surgeon. Maintaining this constant flow is critical. If the flow is interrupted, visibility inside the joint can be immediately compromised. One of the main problems we aim to address occurs when a fluid bag runs empty. When this happens, not only is visibility disrupted, but there is also a risk of air entering the fluid line. This can lead to an air embolism, which is a potentially life-threatening complication. Because of this, it is essential that an empty fluid bag is replaced quickly during the procedure.
that is the problem our system solves. Designed around 3 priorities: alert the room, maintain continuous visibility, and fit seamlessly into the OR.
The objective of our project is to develop a system that improves this process. Specifically, we designed an alert system that provides both visual and audible notifications when a fluid bag is nearly empty. In addition, we incorporated an automatic switching mechanism that closes the depleted line and opens a new one without requiring manual intervention from a nurse.
Starting with the weight sensor system, our bending load cell retrofitted with a custom machined aluminum bracket continuously measures the weight of each fluid bag with a 0.1% accuracy. The signal travels to the HX711 amplifier, which converts it to analog to digital data. The Arduino reads and filters the signal and passes it to the Raspberry Pi. The Raspberry Pi is the system's control center. It calculates the fluid percentage remaining and triggers alerts at the 20% threshold.
Once a low bag is detected, the Raspberry Pi activates the alert system. The visual display shows the fluid levels so the user can clearly see which bag is low. At the same time, the LEDs change from green to red and the buzzer sounds to provide an immediate warning. This gives operating room staff both visual and audible feedback, which helps reduce the chance of the bag running empty without anyone noticing. The second major component of our design is the automatic bag switching system. The motor moves the rack into position so that it pinches the tubing line of the bag we want to close off. The system stops fluid flow from the low bag and allows flow to continue from the fuller bag instead. Ideally, the full process works automatically. The load cell would detect when one bag is low. That information is then sent through the Arduino to the Raspberry Pi, and the Raspberry Pi triggers the motor and moves the rack into the correct position. This creates a system that not only monitors fluid levels, but also responds in real time to maintain continuous fluid delivery. Instead of relying on someone to notice the low bag and respond in time, the system can handle that transition automatically. This helps reduce staff workload, improves efficiency in the operating room, and lowers the risk of interruption in fluid flow during the procedure.